Hi, in this lesson you'll learn about slopes of lines and how to compute them. Key terms you need are rate of change, slope, and XY plane. Every time you think of slope, if you think of some mountain or some cliff, and that's not what we are talking about. Although those are beautiful nature gifts, but that's not our focus in math class. If that's not the case, so what does a slope represent? Now, a slope is, by definition, a rate of change. Okay? Let me give you an example. Let's say a tree grows 2 inches per year. That is a slope of a line. That is an example of a slope because it's a rate of change over time, meaning the tree is growing 2 inches every year. Let's say you go to a gas station and let's say you know you're pumping gas 3 gallons per minute. That's also an example of a rate of change because every minute you have 3 gallons of gas in your tank. Let's say you are either increasing 2 pounds per year. I'm talking about your body weight. Hopefully it's decreasing, but sometimes let's say your body is increasing 2 pounds per year. That is an example of rate of change. That's an example of a slope. Now in your workplace, let's say you are getting paid $10 an hour. That's also an example of rate of change. That's also a slope. In another example, a skier is moving at 40 miles per hour and it is a rate of change from point A to point B at 40 miles per hour. That's an example of a slope. If you see water flow at say 4 gallons per minute, it's also an example of a slope. Now, a rate of change means something that increases over time. That does not have to be related to trees or gallons of gasoline in your car. It could be anything that has something that changes over time. Now, there are 4 types of slope that represents different types of rates. So let's look at those. Now, when we talk about slope, we are using 2 points to represent those slope. So for example, we have a positive slope. Now, when we look at a positive slope, we are representing between 2 points. That is a rate of change that's constantly increasing. That is also a positive slope. It's moving upwards, okay? And we have a negative slope, which represents a constant decrease or decline. And we use 2 points on a number line or XY axis to show that the rate is decreasing at a constant rate as you see it. Okay, that's moving downwards. We also have zero slope. That means the rate does not change, it remains the same. And we can represent it by taking 2 points on XY plane, and it's going to be a horizontal line. We have a scenario where we have undefined slope, meaning it has neither positive nor negative or zero slope, and it's represented by a vertical line, and we can take 2 points to represent those. That's going to be a vertical line, it's undefined slope. Please keep in mind, slopes represent rate of change. Now, how do we find a slope of a line between 2 points? We're going to use a formula. The formula is basically representing 2 points, x1, y1 and x2, y2, and we're going to use this formula to show the change in the y direction and the change in x direction, and then we find the slope. Every time you remember a slope, remember it's a rate of change. Now we have 2 points given to us, and example 1 is point 2 and 3 and 5 and -6, and we're going to use the formula to find the slope. So x1, y1, and then we represent x2, y2. Okay, this makes it a lot easier when you solve the slope formula, and make sure you represent x1, y1, x2, y2. Then write the formula. So we have y2 minus y1, x2 minus x1. Now let's plug it in. So we have y2 is -6, and we have minus, and y1 is 3, and we have x2 is 5, minus x1 is 2. So we have -9 over 3. When we simplify that, we get -3. Now this slope is -3. That means this slope is decreasing, and as we looked at it earlier, the slope is going down. It's a negative slope. Let's do example 2. We do exactly the same thing, x1, y1, x2, y2, and we write the formula again. So the formula is y2 minus y1, x2 minus x1. We plug in the values. That's 6 for y2, minus y1 is 4, and we have 4 minus 5. So we have 2 over -1. Again, this is also a negative slope. Okay. Let's do example 3. We have x1, y1, x2, y2, and we write the formula. y2 minus y1, x2 minus x1. So we have -6 minus 4, and we have -2 minus -2. So this is going to be -10, and we have -2 plus 2, and this is -10 over 0. Anytime any number we have 0, it's going to be undefined. This slope is going to be undefined. Let's see the last slope. We have x1, y1, x2, y2. Again, we write the formula, y2 minus y1, x2 minus x1, and we have 5 minus 5, and we have 6 minus 4, and this is going to be 0 over 2, and the slope is going to be 0 slope. Okay, now we know how to calculate the slope of a line between 2 points. The next one we're going to do is how to find a slope of a line from equations. Let's say you are given an equation and how to determine the slope of the line. Here's the first one. Now, before we do that, we have to keep in mind we have y equals mx b plus form. We have to change all equations into this form so that it will be much easier to find the slope. So here's the slope is given to us as m. So if we rearrange all equations into slope-intercept form, we should be able to find the slope easier. Now, sometimes the equation is given to us in y equals mx b plus form. That time it's going to be a lot easier. Let's do the first example. We have y equals -3x plus 5. As you can tell, this is in the form y equals mx b plus form. So the slope is, in this case, is a coefficient of x, which is going to be -3. That's much easier. If you look at the second example, 4x minus 5y equals 3, it is not given in a y equals mxb plus form. So we have to rearrange. To do that, we have to have y and mx b plus 4. So to do that, I'm going to subtract 4x from both sides of the equation. So we have negative 5y equals negative 4x plus 3, and I'm going to divide each one of the terms by negative 5. Divide by negative 5, divide by negative 5, divide by negative 5. So we have y equals negative cancels out. We have 4 over 5x, and we have negative 3 over 5. Now the slope is going to be 4 over 5. It's a coefficient of x. So that's our slope. So to find a slope of any line, we have to rearrange the equation to y equals mx b plus 4. That would be a lot easier. Now let's see, if we are given two lines on the same xy plane, how do we determine if they are parallel lines or perpendicular lines? Okay, as you can tell, the first two lines, let's call this L1, line 1, let's call this L2. L1 is parallel, I'm going to write in short, to L2. Okay, let's see, the first one has M1. Let's call the first line has M1, which is the slope of the first one. Let's call the second one has a line M2. Now, if line 1 is parallel to line 2, here's what we should remember. The slope of 1 is going to be equal to the slope of 2. So both lines would have the same slope. So parallel lines would have the same slope. Keep that in mind. Okay, now let's see, if we have two lines, if they are perpendicular. Perpendicular means if they make a 90-degree angle. Okay, now what kind of slopes would they have? Let's keep this in mind. Let's call this L1, line 1, and let's call this line 2. Okay, it doesn't matter which one we call line 1, line 2, but I just call them line 1 and line 2. For this line 1, let's call the slope as M1. Okay, the line 2, let's call it M2, which is slope 2. Now, if these two lines are perpendicular, I'm going to write it right here. If line 1, I'm going to write in short, perpendicular, that means it makes 90 degree to L2. Okay, what happens is, if we take the product of slope 1 times slope 2, it is always going to be negative 1. Okay, keep this formula in the back of your mind anytime you work on two lines and finding out if they are parallel or perpendicular. If the two lines are parallel, which is the first type, the two slopes will be the same. Okay, if the two lines are perpendicular, meaning may make 90 degree, they intersect and make 90 degree, what happens is, if you take the slope of the first one times the slope of the second one, you'll always get a negative 1. That's how you prove that. Let's take this concept and apply it. Okay, example 7. We have been given two equations. The first one is y is equal to 3x minus 1. Well, we know the slope of this one is going to be 3. Now the second one, let's find out what the slope is. To do that, we have to rearrange it because it's not given in terms of y equals mx b plus 1, but it's a lot easier. So let's add 3x on this side and 3x on that side. So we have y equals 3x plus 5. Again, the slope of the second one is also 3. So what can we conclude about these two lines? These two lines are parallel lines. Parallel lines. Okay. All we have to do is find out what the slope of each line is, and if they are the same or if they are equal, the lines will be parallel. Let's do the second two equations, the second equations. So the first one, the slope is going to be very obvious, y equals 2x minus 4, and the slope is 2, okay? Now the second one is not too obvious, so we have to rearrange it to find out what the slope is. To do that, I'm going to divide each one of the terms by 8. So that means y equals, if I simplify that, that's going to be negative 1/2 x, and if I simplify that, it's going to be 1/4. Now, the slope of the second one is going to be negative 1/2. Now, by just looking at it, the slope of the first one is 2, the slope of the second one is 1/2. Now, I know they're not equal, therefore, I know for sure they're not parallel. But I want to prove if they are going to be perpendicular, if these two lines make 90-degree angle, if they intersect. To check that, what I'm going to do is I'm going to multiply 2, which is the slope of the first one, times the slope of the second one, and 1/2. When I multiply this, basically 2 times negative 1 is negative 2, 1 times 2 is 2, then when I simplify that, I get negative 1. Okay, this means the two lines are perpendicular, meaning they make a 90-degree angle. That's all it means.